Okay, number 19. One of the minerals that made up the gemstone is jadeite, which can be represented by the formula NaAlSi2O(X). We don't know how many oxygen atoms are there in a formula unit of this jadeite. The percentage by mass of oxygen in jadeite is 47.5%. Now, how do you calculate this percentage of mass of oxygen in this whole compound? How do you calculate that? Okay, basically how you calculate that is the AR of oxygen, which is 16, times the number of oxygen atoms, so that means 16x, divided by the MR of the entire thing, which is 16x, plus Na is 23, Al is 27, okay? So this is all these are basically the AR. And then plus Si is how much? Silicon. Silicon is 28. Okay, I think I make a mistake here. 28, and then times 2. Okay, because there are 2 silicon atoms. And then this whole thing times 100%. Okay, actually no need. This one equals to 0.475 because 47.5% is actually 0.475. So if you work it out, you get 16x. Okay, this one I forgot to calculate beforehand. So this is not good. Okay, 28, right? Okay, plus 27 plus 23, 106. So it's 16x plus 106, 0.475. Now, if you work it out, if you work this thing out, 106. You will get 7.6x plus 106.475, 50.35, and if you work it out, you get 8.4x, 50.35, and your x should be 50.35 divided by 8.4. There will be 6. X is actually 5.99 something, which is 6. So the answer is D. Okay? Yeah, so basically to find out what is X. Okay, X is at the numerator and also at the denominator. That's number 19. Okay, let's look at number 20. Number 20, ammonia burns in oxygen, forming nitrogen and water according to the equation. 40 cm³ of ammonia. See, this is the gas. Okay, ammonia is a gas, right? 40 cm³. This is the volume of the gas. Was burned in 50 cm³ of oxygen. So I have 40 cm³. This is 50 cm³. You see, the mole ratio 4:3 equals to the volume ratio. For gases, mole ratio equals to volume ratio. So mole ratio equals to volume ratio. This one is for gases. What will be the total volume of gases? Total volume of gases at the end of the reaction. So mole ratio NH3 oxygen, you have 4 mole 3 mole, which means that if I have 40 cm³ here, this is 4 mole 3 mole, right? So I have 40 cm³, So this one would be 30 cm cube. So which means that 40 cm cube of NH3 will need 30 cm cube of oxygen to react. Okay, I need 30. What is available? How much volume of oxygen is available? It's 50. So which means that 20 cm cube of the oxygen will be unreacted, which means that this 20 cm cube of oxygen would remain at the end of the reaction. Okay, and how about the nitrogen? Nitrogen, this is 2 mole. So 40, 30, 20. So 20 cm cube of nitrogen will be formed. So this 40 cm cube of ammonia will react with 30 cm cube. So after they react, this 40 and 30 will be gone. They form 20 cm cube of nitrogen, as well as the other 20 cm cube of oxygen would remain unreacted. So at the end of the experiment, 20 cm cube of nitrogen as well as 20 cm cube of oxygen would remain at the end of the reaction. So total 40 cm cube of the gases. Number 21. 100 gram of brass made up of 70% copper, 30% zinc by mass reacts with excess dilute hydrochloric acid. Now, you need to know that copper, no reaction with acid. Okay, copper doesn't react with acid. Which chapter? Metals chapter, chapter 14. Does zinc react with acid? Yes, zinc does react with acid, but copper, silver, gold don't react with acid. What is the volume of hydrogen gas produced at the room temperature and pressure? So you have zinc, HCl, you get zinc chloride, hydrogen. Alright? Balance. Now, how much of the zinc is available? 30%. 30% of 100 gram is 30 gram. So I want to find out what is the volume of the hydrogen gas which is produced. So you only look at this and this. So what is the mole ratio? Mole ratio, zinc, H2, which is 1 mole, 1 mole. Now, how many mole of zinc is available? This is actually 30 over 65, which is 0.4615 mole. So if I have 0.4615 mole of zinc, I should get 0.4615 mole of hydrogen, which means that the volume of hydrogen is the number of mole, which is 0.4615 times 1 mole occupies 1 mole of any gas at room temperature and pressure occupy 24 dm cube. So if you work this out, you should get around 11 dm cube, which is A. Okay. 22. Which of the following are uses of sulfuric acid? Now this one is in the acid bases chapter, chapter 11. Okay, acid bases chapter, which is chapter 11. Okay, it is sulfuric acid. It is used to make detergent, fertilizer, as well as car battery. It doesn't use to sterilize the water. So C. Okay, number 23. Number 23, pieces of apple usually go brown when they are left in the air for a few minutes. In the food processing factory, it is important to prevent this browning from occurring. The graph shows how browning is controlled by the pH of a solution. So, different pH, the apple will go brown at different rate. To prevent browning, cut apples are contained in special solutions. See, time needed for apple to go brown. So at this point, 60 minutes. It takes 1 hour for the apple to go brown, provided that it is in what solution? Provided that the apple is in what solution? It is in around pH 3. So which of these Which one of these solutions prevent browning most effectively? pH 3. Okay, so from the graph, you can conclude that low pH take longer for apple to go brown. Okay, the lower the pH, the longer it takes for the apple to go brown. Number 24. Two types of oxides. One giant molecular. See, giant molecular. This is the chemical bonding. What are the substances in chemical bonding? In covalent bonding, chapter 7 has giant molecular structure. So you have to recall. One ionic, required to make colored glass. Colored. That means colored compound. So you need to know that transition metal. Okay, transition metal form colored compounds. This is what chapter? This is periodic table chapter, which is chapter 16. Okay, transition metals, they form colored compounds. For example, copper. Copper is a transition metal. Copper compound is colored. Which of the following combination of oxides is likely to produce colored glass? So you must have a transition metal in the compound. You must have an ionic. You must have a giant molecular structure. So silicon dioxide, giant molecular structure. Cobalt. If you look at your periodic table, it is the transition metal. Cobalt is a transition metal. So transition metal basically it's all this transition metal. Okay, cobalt is here. So the answer is D. Okay, number 25. The following reactions are carried out. Aqueous ammonium carbonate is warmed with aqueous sodium hydroxide. Sodium hydroxide is an alkali. Ammonium carbonate is warmed with alkali. See, this one, ammonium carbonate. Ammonium carbonate is a carbonate. It is also an ammonium salt. See, ammonium salt, alkali. So this one is from the acid bases chapter, chapter 11. Ammonium salt plus alkali, and you have to warm it. You should get ammonia, you should get salt, you should get water. This reaction must remember. So this gas here must be ammonia. So it's either A or B. C and D out already. How about the second reaction? Dilute ethanoic acid. So ethanoic acid is a weak acid, vinegar. It's added to aqueous ammonium carbonate. See, this one is carbonate and acid. Carbonate and acid. Remember, you have carbonate and acid. What do you get? You get carbon dioxide, salt, and water. So your F must be carbon dioxide. F must be carbon dioxide. How about D? How about the third reaction? Dilute ethanoic acid added to aqueous ammonia. Now aqueous ammonia, you know that this is a base. Acid base, salt, and water. So this one must be the salt. Now remember the name of the salt. So for example, okay, this one for example, HCl is an acid, right? NaOH is a salt, correct? So you get sodium chloride plus water. See, this is the salt. Now remember the name of the salt. The sodium, it's from the base. So in this case, the salt, the first name, the positive ion of the salt must be from the base. Must be from the base. So ammonia, it would give ammonium. How about the negative ion of the salt? it must be from the acid, negative ion of the salt. That means this part must be from the acid. What acid do you use? Ethanoic acid, which means that it must be ethanoate. Cannot be carbonate. Where does the carbonate come from? Okay, so this is the negative ion of the salt must be from the acid. Since the acid is called ethanoic acid, so the negative ion of the salt must be ethanoate. It sounds alike. Just like this one, chloride. This is hydrochloric acid. Sodium chloride. So the chloride is from the hydrochloric acid. Okay, so the answer is B. Quite a challenging question. Alright, number 26. Hydrogen has the formula, this one. It has similar properties to ammonia. Ammonia is NH3. Which property will hydrogen have? Now, dissolve in water to give hydrogen ion. Hydrogen, similar properties to ammonia. Now, ammonia dissolved in water, what ions does it form? It forms hydroxide ion, not hydrogen ion. Okay, this is a base. Ammonia is a base. It is not acid. Acid then dissolved in water to form hydrogen ion. It is an ionic compound. Is it ionic compound? Nitrogen, hydrogen, they are both non-metal. Cannot be ionic compound. The ionic compound must be metal and non-metal. Reacts with alkalis to form salt. Hey, ammonia is a base. How can base react with alkali to form salt? So the answer must be D. But if you look at the D, it reacts with hydrogen chloride to form a compound. Hydrogen chloride is HCl. Let's look at ammonia, okay, because it says similar properties. So ammonia and HCl. Acid, base, it will form salt. So this salt is NH4Cl. Basically just combine NH, this H become here, combine 4 and then Cl. Okay, basically they just combine. So if this hydrogen has similar properties as ammonia, it should work similarly. Which means that H2, your hydrogen are H2 and H2, right? And then you react with HCl. So this part will just combine with HCl, become NH4Cl. This part will combine with another HCl to form NH3Cl. This one and this one, isn't it the same? Similar. Oh, sorry. H, this one is 3. Yeah, it's 3. Yeah, they are the same. Okay, so when it says similar properties, you try to recall the properties that ammonia have. Okay, this one is not in the syllabus, but it says similar properties, but this one is in our syllabus. That is why we can just recall all the properties of ammonia and try to deduce it. That's 26. Now let's look at 27. Let's look at 27. Many properties of an element and its compound can be predicted from the position of the element in the periodic table. Which property of an element cannot be predicted? Metallic, non-metallic can be predicted, but look at the staircase. Okay, to the left hand side of the staircase, that will be metallic. Right hand side of the staircase, that will be non-metallic. Acidic or basic nature can, because this one, all the metal oxide, they are all basic oxide. And then all the non-metal oxide, they are the acidic oxide. Of course, metal oxide, all metal oxide are basic oxide. This one is with the exception of the zinc oxide, ZAP, zinc oxide, aluminum oxide, as well as lead-2 oxide. The formula of its oxide. Well, if you know the position of the element in the periodic table, you know which group they are in. Basically, a position means it can be the group number, it can be the period number. Yeah, if we know the group number, then we know the formula of its oxide, because group number will tell you the charge of the ion that the atom forms. Okay, the number of isotope, this one we don't know. This one impossible to know. For example, chlorine. Chlorine has two isotopes, right? Chlorine 35 and chlorine 37. Where is chlorine in the periodic table? Chlorine is here. It is in group 7. Group 7, it has two isotopes. Group 7, two isotopes. Why? How do I know? That's why the position of the element in the periodic table cannot tell me how many isotopes the element has. 28. Which two statements indicate that metal M may have proton number between 21 and 31? Proton number 21 and 31, that's the top number. Proton number 21 and 21 to 30, right? That's the transition metal. All these are the transition metal. So you try to recall the properties of transition metal. It conduct electricity. Actually, transition metal conduct electricity because all metals conduct electricity. But non-transition metal can also conduct electricity. So it doesn't indicate, okay, which two statements indicate that metal M may have proton number. This one, because the non-transition metal also can conduct electricity, so it basically this statement doesn't indicate that it could be a transition metal. Cannot. Does not react with water. No. Forms two basic oxide. Two basic oxide. So what does it mean? It means if you work it out, it means that this MO consists of M2 plus and O2 minus. This one consists of M3 plus and O2 minus. See? This one, what is the oxidation state of the M in MO? Plus 2. Oxidation state plus 3. So this one is variable oxidation state. Variable oxidation state, which is one of the properties of the transition metal. All transition metal, they have variable oxidation states. Okay? And then it forms two colored. Colored. So all transition metals, they form colored compound. Only transition metal form colored compound. And only transition metal have variable oxidation state. So it's 3 and 4D. The Ionic equation shows the reaction when an aqueous halogen is added to aqueous bromide ions. Which of the following shows the identity of X2 and observations for the above reaction? Now, added to bromide ions. Okay? So it is as if like this. Bromide ions, that means that it must be a salt solution. So you can actually write it down like this. Of course, the positive ion of the salt we don't know, but it will be easier if you write it like this, so that it's easier for the C. Same thing, 2x minus. I can just like that. It's the same thing. The Ionic equation for this reaction would be this one. This one I find it quite difficult to see. But if I write it out like this, that means I don't want to look at the Ionic equation. If I write down the chemical equation, it's very obvious that Br gets displaced by X. That means that X is more reactive than Br. So what is more reactive than Br? Must be chlorine. Because group 7 elements, as you go up the group, for group 7, as you go up the group, the reactivity increases, and chlorine is above bromine. So it must be A or B. Then how about the observation? You see, aqueous halogen is added to aqueous bromide ions. Now, what is the color of this? This one is colorless. All the group 1 compounds, the solution must be colorless. So same thing, this one also colorless. These are bromine, aqueous bromine or bromine solution. The color is reddish brown. So this one colorless become colorless and reddish brown, become colorless and reddish brown mixed together is reddish brown. So colorless to reddish brown, colorless to reddish brown. So the answer is A. Okay, number 30. Lithium and potassium belong to group 1 of the periodic table. Nonsense, I know also. Which element has a higher melting point and which element reacts more vigorously with water? Now, this one this one is from the periodic table chapter, which is chapter 16. You need to know the trend of group 1. So group 1 is like this. Group 1 is moving down the group, moving down group 1 trend, moving down the group, reactivity increases. What else? Reactivity increases, melting point decreases. So which means that your potassium should have a lower melting point than lithium. Lithium should have a higher melting point. More vigorous reactivity, potassium is below lithium, right? So lithium, higher melting point, potassium, more vigorous. So the answer is B. So you need to know the trend of the different groups. Group 1, group 7, these two you need to know. Okay, with that, remember, write down all the things that I've written down, revise the chapter. Very important to know from which chapter the questions come from.